Hello everyone, and welcome to my tutorial on partial fractions. In this tutorial, I'll be introducing you to the concept of partial fractions and showing you how to use them to solve rational expressions. So partial fractions are a way of separating algebraic fractions when the denominator can be factorized into two linear factors. So for instance, we have this fraction with a quadratic denominator, and we can write this fraction as the sum of two fractions with linear denominators by factorizing this quadratic. And then we need to find the values of a and b. Okay, so to start with example 1, we want to express this fraction as the sum of two simpler fractions, each with a linear denominator, where this a and this b are constants that we need to find. So the first step is to factor the denominator of the original fraction, which is x plus 1 multiplied by x plus 3. So now we can write this fraction as 2 over x plus 1 multiplied by x plus 3. And this will then be equal to a constant we're going to find, over x plus 1, plus b over the other factor, x plus 3. So to find a and b, we need to multiply both sides by x plus 1 and x plus 3. So these will cancel. This division of x plus 1 will cancel with this multiplication, and this x plus 3 will cancel with this one. So now we have 2 is equal to a lots of this x plus 3 plus b lots of this x plus 1. So now to find the value of a, we need to make this x plus 1 equal 0, so all of this will go. So we'll say let x equal -1. Then we can substitute this -1 into each of these. So we get 2 is equal to -1 plus 3 is 2, so 2a, plus, and -1 plus 1 is 0, so this will go, so plus 0, so therefore a must be equal to 1. And to work out b, we can say let x equal -3, because then this bracket will become 0. So let x equal -3, and then we'll substitute this -3 into here. So 2 will equal a lots of 0 plus -3 plus 1 is going to be -2, so -2b. We'll cancel out this positive here. So 2 will equal -2b, so therefore b must equal -1, okay? And now we can substitute these two values of a and b back into our original equation. So this will be equal to 1 over x plus 1 minus 1 over x plus 3. So this fraction with a quadratic denominator is exactly the same as this. So now let's look at a slightly more complicated example. So we want to express x plus 1 over x squared minus 8x plus 15 in the form of what we have here, where we have linear factors. So again, the first step is to factor this denominator, and this gives us x minus 3 and x minus 5. So now we can write this fraction as x plus 1 over x minus 3 times x minus 5 will equal some constant over x minus 3 plus a different constant over x minus 5. And now to find a and b, we need to multiply both sides by x minus 3 times x minus 5. We can see that these will cancel. This x minus 3 will cancel with this one, and this x minus 5 will cancel with this one. So now we have x plus 1 is equal to a multiplied by x minus 5 plus b multiplied by x minus 3. And to work out a, we can make this bracket equal 0. So we'll say let x equal 3. And then we'll substitute this 3 in place of x. So we get the 3 plus 1, which is 4, is equal to 3 minus 5, so negative 2a. And we know that this bracket is 0, so all of this becomes 0. So therefore, a must be equal to negative 2. And to work out b, we'll let x equal positive 5. And then we'll substitute the 5 in place of x. So we get 5 plus 1 is 6. And that is equal, this will go. So 5 minus 3 will give us 2b. So therefore, b must equal 3. And then we'll substitute this a and b back into our partial fractions. So we get minus 2 over x minus 3 plus 3 over x minus 5. And to make this a little bit tidier, we'll have a positive 1 first. So 3 over x minus 5 minus 2 over x minus 3. Okay? So finally, let's look at a more challenging example. We want to express 2x squared plus 4 over x lots of x minus 1 times x minus 4 in this form, where a, b, and c are to be found. So we'll say 2x squared plus 4 over x lots of x minus 1 times x minus 4 is equal or identical to a over x plus b over x minus 1 plus c over x minus 4. And now we need to multiply both sides of the equation by x times x minus 1 times x minus 4. So these terms on the left-hand side will cancel. This x will cancel with this x. This x take away 1 will cancel with this 1. And this x take away 4 will cancel with this 1. So now we get 2x squared plus 4 is equal to a multiplied by x minus 1 and x minus 4 plus b lots of x and x minus 4 plus c lots of x and x minus 1. And if we let x equal 0, then we can see any product with x will also equal 0. So a b term will go and the c term will go. And then we'll substitute x into here and we get 2 lots of 0 plus 4, which is 4, is equal to 0 minus 1 times 0 minus 4, which becomes a positive 4a. These terms will become 0, so therefore a must equal 1. And to work out the b term, we can let x equal positive 1, because then this will go and this will go. So let x equal 1. 2x squared, well 2 times 1 plus 4 is 6. And this will equal to b lots of 1. Lots of 1 take away 4, so minus 3. So therefore, b must equal negative 2. And then to work out the value of c, we need this x minus 4 and this x minus 4 to equal 0. So we'll say let x equal positive 4. So now we get 4 squared is 16, times that by 2 is 32, add for 4 becomes 36. And that is equal to, this will go, and this will go, and then we've got 4 multiplied by 3, so 12c. So therefore, c must equal 3. So finally, we'll substitute these values of a, b, and c back into here. So we get 2x squared plus 4 over x lots of x minus 1 times x minus 4 is equal to 1 over x minus 2 over x minus 1 plus 3 over x minus 4. Okay? So I hope you found this tutorial helpful. If you did, give us a thumbs up and subscribe for more content. For a detailed lesson and worksheet on this topic, head over to my website, missmathematics.com, and there's a link in the description below. Thanks again for watching and take care.